All right, yesterday we talked about absolute minimum and maximums, and that was always on a closed interval because it could happen at an endpoint. Well, today we're going to talk about functions, relative mins and maximums on functions whose domain may be the whole number line. So, that's the wrong lesson. All right, so just so we know what we're talking about when I talk about increasing or decreasing or relative minimums or relative maximums, we're going to identify all of my relative mins and maximums and whether the function is increasing or decreasing. So how many relative mins do I have on number 1? Good. And I'm going to go ahead and name the whole point. So 2 negative, or sorry, what is that, negative 1? Negative 1, and 1, negative 1. And where's the relative max? 0, 0. Good. Relative mins are at valleys. Relative maximums are at your hills. Okay, when we talk about where a function is increasing or decreasing, when you trace the graph from left to right, if your pencil's going down, then the graph is increasing. If your pencil's going up, then sorry, that was backwards. If your pencil's going down, the graph is decreasing. If the pencil's going up, your graph is increasing. And we always talk about the intervals where you're increasing and decreasing in terms of x's. So this first part where your pencil would be going down, the x values that are covered would be from negative infinity to what? Negative 1. Good. So I'm decreasing from negative infinity to negative 1. And then is there another section where I'm decreasing? Right, 0 to positive 1. So it's the x values between those two parts where you're decreasing. Yeah, you can union them. I tend to forget my union. And then the function is increasing between negative 1 and 0, x values, and then between what and what? 1 to infinity. Now, we always use parentheses when we're talking about intervals where we're increasing and decreasing because at this relative minimum right here, the function is really, so at x equal negative 1, we're neither increasing nor decreasing. So it's just all the way up to negative 1. Okay, number 2. Where's my relative min? 0, 0. This little valley right here. Okay, how about my relative max? Yeah, this kind of comes down like that. It'd be about right here. Negative 2. It's a relative, okay, it's a relative maximum, and remember a relative maximum is at a hill. Yes, your relative minimum could be higher than your relative maximum. Kind of weird to think about. That is. All right, decreasing. Whoa. I am decreasing from negative 2 to negative 1. And negative 1 to 0. Okay. We've got an asymptote here at negative 1. So from negative 2 all the way to x equals negative 1, and then from negative 1 to 0. Now, why can I not just write negative 2 to 0? Yeah, the function doesn't even exist at negative 1, so it can't be increasing or decreasing. So I do need to break up that interval. And then I'm increasing from negative infinity to negative 1 and 0 to infinity. So from negative infinity until negative 1, I'm increasing. Oh, is it negative? Sorry. Yes, negative infinity to negative 2 and 0 to infinity. Okay, sorry about that. Okay, now unfortunately, on the AP exam, they're not just going to ask you to identify where the function's increasing and decreasing from a graph. That would be way too easy. We've talked about this some. The derivative of a function that is increasing will always be what? Positive. Good. If your function is increasing, then its slope is positive. And the derivative of a function that's decreasing will always be negative. What is the derivative of a constant function? 0. A constant function is like y equals 5, so a horizontal line. A function will change from increasing to decreasing, or vice versa, where? Very good, at a relative extrema. So a relative min or a relative max. And relative extrema also always occur at critical numbers. Good. All right, and then one more vocabulary word for you. A function is strictly monotonic on an interval if it is increasing on the entire interval or decreasing on the entire interval. So if from negative infinity to infinity, your function is always increasing or always decreasing, it's strictly monotonic. The best example that I can think of is y equals x cubed. That's strictly monotonic because it's increasing on its entire domain. Okay? Oh, you just... Or, yeah. Or a straight line right there. Okay, y equals x cubed. The derivative would equal 0 at x equals 0. It's still considered... Because you're increasing to the left of that point and increasing to the right of that point, it's still considered strictly monotonic. All right, so we're going to test for increasing or decreasing functions. Basically what's going to happen is I'm going to give you the equation of a function, and using that equation and not having a graph of it, you're going to have to determine where the function is increasing and where the function is decreasing. But we can do that by the derivative. So if f prime of x is greater than 0 on an interval, then f is going to be increasing. If the derivative is less than 0, then f will be decreasing. And if f prime of x equals 0, then the function is constant. So what we need to do is take the derivative and figure out where the derivative is positive or negative. So for number 3, the derivative will equal 3, is that x to the third? 3x squared minus 3x. Now a derivative will change from positive to negative where? At a critical number. Very good. So I need to find the critical numbers first. And the critical numbers are where the derivative equals 0 or where the derivative is undefined. Do I have any points where this derivative is undefined? No. So I just set it equal to 0. I can factor out a 3x and get x minus 1. So x equals 0 and x equals 1. So the derivative is 0 at those 2 points. So at all the points in between 0 and 1, or on all the intervals between 0 and 1, my derivative will either be positive or it will be negative. So what I do is I make a little number line with 0 and with 1, and I need to figure out whether the derivative is positive or negative. So I can just kind of use a test point. What's a good test point between negative infinity and 0? Negative 1. Okay, so if I want to figure out whether the derivative is positive or negative, am I going to plug negative 1 into f prime or into f? F prime. Good. It doesn't matter which form you plug it into. I usually like to plug it into the factored form, because if I plug in a negative into 3x, negative 1 into 3x, I'm going to get a negative, and then times another negative. So that's positive. Okay, what do you want to test between 0 and 1? 0.5. Okay, 3 times 0.5 is going to be positive. 0.5 minus 1 is negative. Positive times a negative is a negative. Kelly? It doesn't. Okay, that's a good question. She's basically asking, once you get that first positive or negative, are they always going to alternate? And the answer is no, because if you have a graph that, say the graph of the derivative looks like that, then you're going to go positive, negative, negative. So if you're 0, if you have a double root for a 0, then the graph is going to bounce off of the x-axis, and it'll stay the same. So you can't just automatically think they're going to change signs. But if you plug in a 2, you are going to get a positive. Okay, so we are. Yeah, this would be the graph of f prime. Yeah. If that happened to be the graph of f prime, then the zeros of f prime would be here, but you'd go positive, negative, negative. That does not apply to this problem. I just made that up off the top of my head. All right, now, you're not going to like this, but you have to do it. You're going to have to write something on this. You cannot use this little plus-minus chart as justification. And what you have to write is that f is increasing between negative infinity and 0 and 1 to infinity because f prime of x is greater than 0. You have to write because f prime of x is greater than 0. They're looking for those words. Well, this little chart that we made right here, this is telling me that between negative infinity and 0, f prime is positive, and positive, same thing as greater than 0. Oh, okay. You could write because f prime of x is positive, but I think greater than 0 is easier. No, because if it's equal to 0, then it's constant, and the function, if f prime is equal to 0, the function is neither increasing nor decreasing. And that's why I'm using parentheses here, is that I'm only increasing from negative infinity up until 0, but not at 0. It's a little bit of a technicality there. Try not to worry about that. Well, in this case, we're switching from we're switching signs right here. But back on x cubed, I don't know. Maybe I need to do some research on that. I could be wrong. So let me do some research into x cubed and let you know if that truly is strictly monotonic. Okay, f is decreasing. Where? 0 to 1. Because what? F prime of x is less than 0. Okay. Yes? Are you talking about this graph over here? This graph was a completely different situation that somebody asked about. It has nothing to do with number 3. And that's why I've crossed it off. It was a what if question. All right, once you've identified the intervals at which a function is increasing or decreasing, it's not difficult to identify or classify the relative extrema.